Hello everyone. In today's session, we will discuss about named entity recognition (NER), which is a component of natural language processing. We will go through the following topics in detail, like what is named entity recognition, why and where named entity recognition (NER) is significant, what are the real world use cases of NER, and an example where we use the open source BERT model from Hugging Face to perform NER in Elasticsearch. So let's get started. So let's understand what is NER. Named entity recognition is a component of natural language processing in which you identify and classify different entities within a given information. Entities are nothing but significant data or insights that you can extract from a given information. So some of the common entities that you can find in any document could be a person's name, organization name, location or place, date details, currency information, or measurement data, and it can be much more. So let's consider different examples here. Consider a patient record. It can contain different details, but some of the significant information that you can extract from this patient record can be the patient's name, the hospital or the organization in which the patient has been admitted, the date in which he has been admitted, and what are the treatments that the patient is undergoing. So, treatment can also be an entity here. Yeah, let's consider another example of a property deed. The property deed document can contain different details such as the owner's name, the buyer of the property, the date in which the transaction has taken place, and also like the measurement details. So there can be different entities for that particular document. So entities are nothing but significant or valuable information that you can extract from a vast amount of information. Now let's see why and where NER is significant. The main use case of NER is extraction of important information from unstructured data. In case of structured data, you already have information in a more organized format. But in case of unstructured documents, consider for example a Word document or a PDF document which consists of hundreds and thousands of pages. To extract important information from those thousand pages in a single document is going to be time consuming. And imagine a data corpus which contains multiple documents in various categories. This is definitely going to be a time consuming process. And that is where NER is significant. It can quickly extract the entities, and using machine learning models, this can easily be achieved in a quick span of time. This will be very useful for medical researchers or scientists who need to go through a lot of articles and extract important information. Here I have listed some of the real world use cases where NER is utilized. For example, in e commerce product classifications, in legal document analysis, financial market analysis, news article categorization, healthcare information extraction, and even in chatbots and voice assistants. So far, we have seen extracting key information or entities from vast amounts of data using NER. Now, let's talk about how NER is used in chatbots and voice assistants to extract entities or key information from even small amount of information. For example, consider a chatbot in a banking application. For example, a user enters a query like how to open a savings bank account, and the key or the important information in this small piece of text could be savings and account. So the chatbot will extract these key information or entities and will provide the next level of response. This is how NER is used in chatbots and voice assistants nowadays. So basically, NER can be used in any area of expertise or domain where key data or insights need to be extracted and analyzed. In this section, we will see a simple example on how to implement NER for a sample data set. There are various NER models available currently, but in this example, we will be using the fine tuned version of the open source BERT model from Hugging Face library to perform the named entity recognition. So, if you are interested in knowing about what the BERT model is about, you can check out the documentation from Hugging Face library page. This model is basically a fine-tuned version of the base BERT model, um, which is specifically designed for tasks such as NER, sentiment analysis, and text classification, etc. BERT stands for bidirectional encoder representation from transformers. In simple context, we can um, understand that the entities that are extracted or evaluated will be done in both the directions, like on the left context as well as the right context. Meaning that in both the directions, the context of the given information will be evaluated, not only on the right hand side but also on the left hand side, to understand the context of the given information. So this gives an edge over models which only use the context in the right hand side information. So now let's see the implementation details. In this example, let's import the distill BERT model from Hugging Space library into Elasticsearch to perform NER for a given sample data set. The prerequisites for this particular demo are: we need Elastic Cloud deployment and a Docker installed. I have already installed Docker in my machine and I have used the trial version of Elastic Cloud. The trial version comes with 14 days trial, and also I've created a new deployment with one Elasticsearch node, one Kibana instance, and one ML node. The ML node should have at least 2 GB of memory to import the particular model into Elasticsearch successfully. So once we log into our Elastic Cloud, we can create a new deployment, but the new deployment does not always come with the ML node configured by default. So we need to add the ML node with the respective memory configurations. So let's go and add an ML node with at least 2 GB of memory configuration. Otherwise, the importing of the model will fail. So once we added the ML instance, we can just save the settings, and the particular deployment will be executed successfully. Once the deployment is complete, we can go to Kibana and proceed with the next steps. The next step is to create new user roles and new user to access this particular ML features. So that is the next step. So let's move on to the next step, step 3. The user roles and users can be created in Kibana dashboard. Um, let's open Kibana here. If we navigate to stack management, under the management section, there'll be a section called security, and in this particular section the user roles and users can be created. So this is required for our ML feature configuration. So this is the required step. So let's create a new role, and the only prerequisite is that it should have all cluster privileges. So we should assign all as the cluster privileges and just create a new role. I have already created a role with the all cluster privileges called test role. So this is already created, and let's move on to create a new user. The new user, you can assign any name, and just assign the test role that we just created for this particular user. And once you create the user, you will be asked for username and password credential information. Since I have already created the user, the details are not displayed here. So these details will be required to run the docker command that will be proceeding in the next step. So the username and password needs to be saved. So once the user roles and user are created, let's move on to step 3. In this step, we'll be using the Python eland library to pull the ML model into Elasticsearch. In Elasticsearch, they use the eland library from in Python to import all the ML models. So we'll just first pull the eland library first using the docker command, and then run the below command to import the model ML model into Elasticsearch. So this command, right, will contain the model ID. You can see the model ID. So we have used the BERT model, and also there will be three parameters that we need to modify. One is the Elastic Cloud ID, username, and password. So the Elastic Cloud ID is nothing but the cloud ID of the deployment, Elasticsearch deployment that we just created. And the username and password are the credentials that we created in step 2. So this start parameter is nothing but it helps to deploy the model once it's imported, but that is not mandatory. We can just skip that start and just import the model into Elasticsearch first, and later on we can deploy the model. So this is the cloud ID that I was mentioning. When we create the deployment, right, this cloud ID will be generated, and that is the ID that we should place in this particular Docker command with the username and password that we created. So once we run this Docker command, the particular model will be imported into Elasticsearch, and we can go to the model management page in the Kibana dashboard to view the imported models. Just navigate to analytics, machine learning, and in that we have a section called model management and trained models. Here we can see the model that we just ran through the command is imported, and also it is deployed. Since I have already deployed it, it is showing status as deployed. And in some cases, if there is any issue or warning that you see that the model is not successfully imported or synchronized, you just there will be a display message at the top. You can just click on that and save synchronize objects, and the particular model will be imported. And you will have to just select that particular model in the checkbox and deploy it. Since I have already deployed it, this particular selection is disabled here, but once you import it, this selection will be enabled and you can just deploy. Click on deploy. The status will be deployed, and once it's deployed, we can go to test on the model. And there are other models, right, in this particular section. These are all other models that are provided by Elasticsearch by default. The LSAR model for text embedding features, and the language identification model for basically identifying the language of the given information. And to test the particular model, just click on this particular section here, test model. And since we are going to test NER, right, named entity recognition, I'll just give a sample phrase like this. So let me enter John lives in California. It can be any text with some entities to test your model. Yeah, in this we can see that there are two entities that are getting extracted. One is John and one is California. John is of type person entity, and California is of type location entity. So there are two entities extracted, and the probability score is also mentioned, like it gives us the accuracy whether the extracted entity about the extracted entity. So this is how we test our trained test our imported model. We have just tested our model with a sample example. Now let's create a new index with a bulk data set and see how the bulk inference of documents is just performing with the given imported model. So in step 7, let's create an index with a given sample data set. I have just taken this sample set as my example. You can have your own data set as well. This is a JSON file which contains multiple documents with three fields. There is a line field, paragraph field, and a timestamp field here. The paragraph field is the one which we are going to analyze and get the extracted entities from using the NER model. So this is the main textual data. You can download this sample set as well. And once we download this sample set, we can create a index in our Elasticsearch by just uploading this JSON file. So navigate to integrations under management section, and there will be like integrations that are shown from multiple data sources where you can import data. Since we are just using a JSON file, we can choose like upload a file, and once we upload the file, it will prompt for the index name, like what is the index name that we are going to provide. I have just created an index called test index, and I have just imported the data. If you already have an existing index, you can just skip this step 7. Now once the index is created, the main part comes here, like we have to create an inference ingest pipeline. So I have just given a name called NER for this pipeline. The pipeline can be created either via using the interface stack management itself. Like if you just navigate to stack management, there'll be a section called ingest pipelines. You can just click on create pipeline and add the required details there, like whatever fields you are going to use for this ingestion purposes. You can specify all those details, or otherwise use the given put command to create the pipeline as well. So I'm just using this Kibana console here. I have also run this command and created the ingest pipeline. So it is just a simple pipeline here with the inference processor created, and the model ID that is present here. This is the model ID that we just imported into Elasticsearch. If we go to the Docker command, we can see that yeah, the model ID is mentioned as this one: Distilbert base uncased fine-tuned English model. So this is the model ID, and also the field names are given here. So target field is nothing but when the entities are extracted, this is the field name in which the value should be stored. So target field, and this is the source field from which our whatever field we are going to analyze, right? So that is the source field. In our case, it is going to be the paragraph. And there is also a small script in which there is a field called tags which is created, that will hold all the values of the different entities that we are going to create. We will look into the script section later once we analyze the output. It will be easier to understand that later. So this is the small script section, and also there is a failure section, which in case if a document fails during the ingest pipeline, it will denote the ID of the document. It will store the ID of the document for further processing. This is not a mandatory parameter, but for production environments, this is very much necessary. So I have already run the ingest pipeline and created the NER pipeline. So the pipeline is ready. So the next step could be like we have the source data and we have the pipeline. We'll just create a new index called NER index using this given pipeline. So in step 9, we'll be using the reindex command to push the data from the source index to a new index called NER index using the pipeline NER. So basically, the documents in this particular test index will pass through this NER pipeline to the new index, NER index. So the NER index basically will contain all the entities that are extracted. So I have also run this command as well, and the new index called NER index is being created. Once the index is created, we can just run a query to see what are the entities that have been extracted. So I have just run a match all query here. We will see the different documents. So in the first document, if you can see, there is a field which has been created like ML. Under that, it's like a nested field. Under ML, we have a field called NER, and under NER, we have the different entities that are listed here. So this is the source field paragraph from which the different entities are extracted. The values are all can be seen in the predicted value itself, and the different entities are just listed as in the JSON array. So here we can see there are three entities of type person which are just captured in that particular paragraph. And we also have a tags field which will just create like aggregate all that particular data and store it in a single field. So basically all the documents in the source index will have the entities extracted. So let's move on to see another example where we'll have like different class of entities. Yeah, in this example, if you see, there is a there are two entities which are extracted. One is of type person and one is of type location. So two entities are extracted, and they are stored in the tags field under different class types like location and person. So for all the documents, we have the different entities that are extracted. If there is no entity, the particular entity section will be empty. So now let's move on to the script that we created, right? The pipeline script. Now we will have a better understanding. So the target field is ml.ner, which is created here, and under that we see the entities, different entities getting extracted. And the source field is the paragraph field. And the script is also like a simple script where we create a new field called tags, which is like an hash map where we store all the different entities that are extracted from the document. So this is what is happening in the painless script. So this is how the NER, like using the model, right? Using the pre-built model, we have used our source index to generate the index with extracted entities, and you can perform a search on these new index as well from your application. So there are a lot of possibilities here to search or to like visualize or to do some analysis. So all kind of possibilities are there. So this is the main output. This is all done, and step 11, this is like an additional feature, like where we can view the extracted entities in kind of a dashboard or visualization that you want for performing some kind of analysis, or just you want to just view the data in case. So this is also possible using Kibana. So if we go to navigate to the Kibana dashboard, and there is a tab called, I mean, a section called Analytics. In that we have a Discover tab. Under the Discover tab, to create visualizations, we need to create a data view for the particular index. So click on Create Data View and just give any name, and in the index pattern we'll have to specify our index. So since our ner index contains all the entities, right, I have selected that, and as of now ignore this timestamp field and save the data to Kibana, data view to Kibana. And once the data view is created, we can perform visualizations as required. And here on the left hand side, you'll be able to see the different fields that we saw in the index. And this is like basically, um, in any index you can create visualizations, right? So this is similar to, very much similar to this. So for the given output tag field, we are going to create visualizations. Here we'll just navigate for yeah, we can create a tag cloud, a pie chart, a bar chart, whichever is required, whichever is just preferred. I'm just modifying the count of values to 30, and here you can see, like these are the top 30 values of the um, organization entity that is present in our index. The top 30 values are listed here like a tag cloud. So if you want to modify it to a pie chart or a bar chart, you can do so. So you can also view yeah, there. Let's move, let's try on like tags dot person or location, whatever entities that are available. Here you can see this is like a tag cloud for the top 30 person entities. So these are the names that are present in our new index. You can create any type of visualization in Kibana, like the chart pattern, right? You can select anything. So let's modify it to a pie chart. So this kind of visualization helps in analyzing the data more clearly, like what type of data is more dominant, what is at least. So this will kind of, this is kind of an analysis that you want to perform on your data. You can um, like perform using this data view. And this is the end of the NER tutorial. And this is the current pre-built model that we are currently using for performing this NER in Elasticsearch. In case you wanted to have like different classes of entities other than like person, organization, or location, you like for your particular documents, right, you may have a different kind of entities that you want to extract. So in that case you can create your own custom models, train your model against training data set, and also perform NER. Yeah, that's it. Thank you guys for watching. If you like to perform the detailed steps, you can check out my blog post. Hope this is useful. Yeah, thank you.